They're saying, what is a projectile motion? That's what the question is saying. What is a projectile motion? Who can define for us that? Unmute and then please let's all unmute and we talk. If you want to say something, unmute and then we continue, please. What is a projectile motion? Who can give us that?
Projectile motion is the motion of a body which, after being given an initial velocity, moves under the influence of gravity.
Move under the influence of? Move under the influence of gravity. So, is a type of motion, is a type of motion in which when a body is given initial what? Velocity. Initial velocity is a type of motion in which when a body is given initial velocity, it moves or is left and is left to move under the what? Under the influence of gravity. Okay? Now, members, when you look at this question, the question is saying what is. I remember they explained at that time very well. There's a difference between what is and define. They may say define projectile motion is different from what is projectile motion. In definition, you be precise. You only give a definition and you don't add anything. But if a question is what is, that's why many students fail physics, because they don't know how to interpret questions. You may find that they may give only a half for this. For there you have only defined. This one you have defined. But the question is saying what is a projectile motion? So you say a projectile motion is a type of motion in which when a body is given initial velocity and left to move under the influence of gravity. Full stop. Full stop. Now, what other information? Now, when the question is what is, in what is, you define and then give me relevant what? Relevant what? Comments. What else? Which comment are you going to give me? You have already defined. What relevant comment are you going to give me here? You can say it describes a path which is what? Parabolic in nature. It describes a path which is parabolic in nature. Those are the relevant comments we're adding. That's what I expect, giving a solid answer to a given question. Are we together, members? And we have seen there are 3 cases here. What are some of the examples we can give? We gave of throwing objects from a plane. That one also, these are now examples of projectile motions. In case they ask for it, because they may say, what is a projectile motion, and give example of projectile motion. One of the example is throwing objects from a plane or objects released from plane. That is one. Batting in crickets. Okay. Then another example is throwing stones. Those are another one. Throwing stones, or just throwing objects from the ground. To a given what? Angle. To a given what? Angle. Members, do you remember that? And we look at some of the terms. Now let's look at this question in particular. So we have answered that question. Those are the relevant comments you give. Projectile motion is a type of motion in which when a body is given initial velocity and is left to move under the influence of gravity. Full stop. It describes a path which is parabolic in nature. Or you can say throwing a stone. You can give example includes throwing a stone from an aeroplane, throwing objects from aeroplane, an object released from aeroplane, batting in crickets, football, planetable. Those are the relevant examples, comments you can add on. Now, when you look at Roman 2, they're saying a bomb is dropped from an aeroplane, which is directly above a target at a height of 1,402.5 meters. The aeroplane is moving horizontally when the speed of at a speed of 500 kilometers per hour. Determine whether the bomb will hit the what? The target. Members, are you with me? Members, are you listening to me?
Yes, teacher.
Good. Now, I'm looking at question Roman 2. Roman 2. Let's answer that question. If you remember very well, we said there are 3 cases here under projectiles. One, a body projected from the ground to a given angle. The second one, when a body is projected from a given height, this is above ground level. When a body is projected from height above a given height above ground level. Then 2, when a body is projected horizontally, above a ground level, above the ground level. So those are the 3 cases we look at. And we have derived all equation, and we have looked at the terms we use to describe them. Now, when you look at this one, so the first thing is you sketch. You give the sketch for that. Let's look at solution for that. So I'm assuming this is the height. This is the height. Now this is our ground level. The ground is there. So the plane is moving horizontally. But it has a given height of, what's the height? It is 1,402.5 meters above the ground level. And the plane is moving horizontally. So which means the object will move like this. You see the path it's describing, and the plane is, which means the velocity must be horizontally to the ground, to the horizontal. I think that. So this one will be like this. So this is our initial velocity u, which was given to be 500 kilometers per hour. But we know that when we are looking at motion, we say the SI unit of velocity is meters per second. So you don't use in kilometers. You have to convert this into meters per second. Are you together, members? Now, they're asking you, a bomb is dropped from an aeroplane, which is directly above a target at the height of. So now remember, the plane is moving. So which means now they're asking, determine whether the bomb will hit the what? The target. So assuming now the target is here. Remember that when the object is moving, it's moving. So which means the target is here, the plane is here. So the plane is moving like that. Okay? Members, are you together? Are we together? So you need to know this distance, this horizontal distance, x. You need to know this distance. That's the only thing you need, whether it's going to hit the target or not. So this is now what we call the maximum range, or the maximum horizontal, because when you go beyond this, this is the target. Okay? So which means you must calculate for me this distance. Members, are we together? Are we together?
Yes, teacher.
Yes. So can you finish that calculation? Start doing that calculation very fast. Even you see, it's like the way I've explained here in this diagram here. So you convert for me this. In A level, I don't give marks for converting this. You must be able to convert it direct from your calculator. How do we convert direct from our calculator? Don't waste time converting those things like you're still in senior 1. So just convert it direct in your calculator. Let me show you. I want to show you from here. Let me zoom my screen. Members, are you seeing this? These ones. This one we can convert from one unit to another. So like now we want to convert kilometer per hour to meters per second. You see it's number 19. It's number 19. So what you do, you first enter what you want to convert. What do we want to convert? Is what? 500. Is what? 500 equals to. So you press convert 19. Convert 19. So maybe let me first put it. Convert 19. So you, sorry, shift constant 19. I think that. So which means this one shows that you are converting from kilometer per hour to meters per second. So you press what you want to convert. Like here we have 500. 500 shift convert 19. So what do you get? I think that. So which means when you follow that step very clearly, which means our initial speed will be 138.89 meters per what? Per second. So that's the initial speed you are going to use. You are not going to use 500. Are we together? Are we together, members? Members, are we together? Yes. So
we are together.
yes. Now calculate for me this distance. Calculate for me this distance. How do we calculate that distance? How do you calculate that distance? That is distance. We know that distance is given by what? X equals to is what? When you are using, you're using S equals to UT plus or minus GT squared. This is horizontal motion. Okay? Horizontal motion. So which means this one is coming down, which means acceleration due to gravity must be positive. I think that acceleration due to gravity must be what? Positive. So which means the distance X here, which is this, X is going to be equals to our initial velocity, horizontal, because still remain U, it still remains. So that one we shall have U, UT. Remember the body is moving horizontally. We said when the body is moving horizontally, does it have acceleration due to gravity? Acceleration due to gravity will become what? Will become what? 0 meters per second. So which means you remain with only this. You remain with only this. I think that. Members, I think that. So now substitute. But do we know the time? What will be this time? What will be this time, members? We don't know that time. What will be that time? That time will be time of what? Will be time of flight. Will be time of what? Will be time of flight. So can you get for me the time of flight? After getting time of flight, then come and substitute it and then get that distance X. As simple as that. Is it noted, members? Members, is it noted down? We have answered that question. The next part, that one I've already guided you in that. Now they're asking you, the question was whether. So which means you see, when you look at this cancellation here, when you look at this cancellation, they're saying misses the target by what?
Excuse me, teacher.
Yes, please.
You've said that we get the time of flight, but then in the question, you don't have the theta. So how do you get it?
We don't have what?
Theta.
Now you see here, this one is horizontal. Let me take you back to the notes here. When we are looking at horizontal motion, when the body is projected horizontally, I think like this one here.
Yes.
The problem, this thing cannot read, you cannot read PDF very well. Let me show you here. Here, an object projected horizontally from a height above the ground. That angle is 0. The angle is 0. Okay. The angle projection is what? 0, because the plane is the aeroplane is moving what? Horizontally to the plane. So the angle to the horizontal is 0.
Okay.
And what is, remember now we are looking at time. We are looking at time. So if you remember, what is going to be that time?
Pardon?
What would be the time? What would be the time?
I'm still working it out.
Okay. Mm-hmm. What is the time? Okay, you will do it. You will do it. I believe everyone can do that. Now, in case they were asking for the velocity with which, the velocity with which, the velocity with which it was going to eat the target. So which means you are going to say, you come back here. So which means they're asking for this velocity, which means you must get two components here, two components. So we shall have Vy, then we shall also have what? Vx. This is now the velocity with which it will eat the target. This one now. So which means you need to find Vx. I told you how do we find Vx? What will be Vx? Using the equation of motion. Sorry. So our V, which is equals to U plus G dt. Now, if it's Vx, what do you remain with? What do you remain with? Or if you are to use the general formula, you find that we shall have V U Ux cos theta minus plus gt, because this one is now coming down, is in the process of coming down. But the angle is 0. What is cos of 0, members? What is cos of 0? Our angle theta is what? 0 degrees. I want you to look it from the first principle. So which means Vx will be equals to our initial velocity, which was given. We got 138.9 cos of 0. What is cos of 0?
1.
Cos of 0 is what? Is 1. So we know that's why now we stand Vx. It remained the same. It remained the same, which means what? 138.9 what? Meters per second. Are you together? That is Vx. What about Vy? So our Vy will be equals to, our Vy will be equals to, our Vy will be equals to, what will be our Vy, members? What will be our Vy? Remember we said Vy initially from the formula is U plus gt. Not so? The formula still remains that. But what is this? Remember when we are using the general formula, we got Vy is equals to U sine what? Sine theta. Sine theta. If it's coming down, which means it is going to be plus gt. Plus gt. I think that. So Vy is equals to our initial velocity, which is 138.9 sine. The angle is 0. What is sine of 0, members?
0.
Is 0. Plus 9.81 times what? What is the time? The time that you have got. What is that you have got? Which time have you got? I believe you have got that time. So you multiply by that time. For me, I have not calculated that because I told you to do it. So which means you find that our Vy will be equals to G. Yes, Stephen, you got what was the time? What did you get, members? What have you got? What have you got? What was the time taken for the bomb to hit the ground? Which is the time of flight? Which is the time of flight?
6.9.
Is it?
6.9.
6.9, eh? Is 6.9? Stephen, I'm not getting you well. Nalubega, for you, what have you got? Nalubega, what have you got? Sandra, what?
Had got 10.
You have got 10.
Yes.
16.9.
People have different values. Which formula did you use? Tell me the formula you have used. Tell me the formula you have used.
The formula I use for the downward motion whereby h is equals to ut plus a half gt squared.
H equals to?
Ut plus a half gt squared.
Plus a half dt squared. Not so?
Yes.
So what is the height?
1,402.5.
That's the formula you're supposed to use. But remember this one, the height is below the point of projection. So we said when it's below the point of projection, you take it to be what? A negative. You take it to be what? A negative distance. Are you together?
Yes.
Which means supposed to be negative 1,402.5 what? Meters. So when you do the calculation, you're going to see that you're going to form a quadratic equation, all right? Not so. You're going to form a quadratic what? Equation. So let's substitute and we see. Hey, you people, I thought you have done that already. So we shall have h equals to ut plus a half dt squared. So which means our height, which is negative 1,402.5 equals to, what is our initial velocity?
138.89.
138.89 t plus a half times 9.81 t what? Squared. So you find it up negative 0.5 equals to 0.89 t minus this will give you 4 point, is it 905? Huh? T squared.
Yes,
when you,
teacher.
yes.
Yes.
So you see you form a quadratic equation there. So when you solve this, what do you get? I believe everyone has got this. I think it's 16. Is it 16? Something like that.
Yes.
16.9.
Yes. So which means one is negative, the other one is positive. So you take the one which is positive because there's no negative time. Okay.
Yes.
So 16.9 what? Seconds. So now that's the time you are going to come and put it where? Here to get Vy. So Vy will be equals to 9.81 times what? 16.9. So what do you get? What is going to be our Vy? So 9.81 times 16.9. You get what? 100 what? 165.789 meters per second. Not so? Members, is it true? Members, is it true? So this is the velocity in the y direction, in the y direction vertically. Then Vx is there. But we said to get that velocity, the final velocity with which it will hit the ground. So now there you use Pythagoras. You use Pythagoras what? Theorem. So you said V is equals to the square root of Vx squared plus Vy squared. Then remember, velocity is a vector quantity. Velocity is a vector quantity. It must have directions. Velocity is a vector quantity. Is a vector quantity. So which means you must find the direction. So the direction will be, what will be the direction? So we shall say direction will be theta is equals to the arctan of Vy over Vx. Those are the things we have already looked at. So those are the things you must be in position to do. Okay? This is UNEP 2012. They're saying derive an expression for maximum horizontal distance traveled by a projectile in terms of its initial velocity u and the angle projection theta to the horizontal. Members, what do we want you to describe here? What do we want you to derive? What is that distance called? Maximum horizontal distance. What is that? What is that, members? If you remember very well. That's our maximum what? Maximum what?
Range.
Maximum range. We said maximum range. What is the condition for maximum range? If you remember the formula for range is equals to, who can give me the formula? Range is equals to?
U squared sine 2 theta over G.
U squared sine 2 what? 2 theta over what?
Theta.
Over?
G.
Angle theta equals to 45 degrees.
Over G. But for condition for maximum range, for R max, for R what? Max. This sine 2 theta must be equals to what?
45 degrees.
Must be equals to 45 degrees. Now, since they have told you the angle projection theta to the horizontal, so you work it normally, which means the angle projection theta must be equals to 40 what? Must be equals to 45 degrees. I've explained why we are getting 45, because sine 2 theta equals to 1. When you get 2 theta, you get the sine inverse of 1. So what is the sine inverse of 1? Sine inverse of 1 is what? 90 degrees. So which will give us theta is equals to 45 what? Degrees. Members, have you seen that? That's what they wanted you to derive. So you work from the past principle. So you start by drawing. You start by drawing your projectile, the trajectory. Then you derive those formulas. Okay? Are we together? Roman 2, they're saying sketch a graph to show the relationship between kinetic energy and height above the ground in a projectile. So members, what do they want you to sketch here? They're saying sketch a graph to show the relationship between kinetic energy and height above the ground in a projectile. Is there some relationship? Remember, when you remember very well from your O-level physics, we said from the principle of conservation of energy, we said energy can neither be created nor destroyed, but can be transformed from one form to another. So which means if it's a body is at a given height, which means at that maximum height or at that height, it will be having what? Maximum potential energy. Have you seen that? That will be maximum what? Potential energy. But the potential energy, by the time the body reach